Good afternoon, everybody. In this video, I'm going to show you how to complete the simple pendulum online experiment. So the goal of this video is we're going to measure the acceleration due to gravity using a simple pendulum. In fact, you can do this experiment at home. So let's get started. Before going into the data measurement, you have to answer the pre-lab questions. So what are the pre-lab questions? The first question is, what is the acceleration due to gravity? So you have to answer these questions, and you can find the answers from the lecture videos. Then you have to answer, what is the value of the Earth's acceleration due to gravity at the surface of the Earth? Okay, so now if you move to equator or pole on the Earth's surface itself, does the acceleration due to gravity changes? Or when it is maximum, when it is minimum, can you identify those things? So answer this question here. In fact, the acceleration due to gravity depends upon the position, it depends upon the location, depends upon the mass of the planet. So for example, if you go from the Earth to the Moon, the value changes. What's the value of the acceleration due to gravity on Moon's surface? You have to write down here. So now the thing is, if you have a simple pendulum, what is the relation between the time period, the length, and acceleration due to gravity of a simple pendulum? Okay, and I will give you the hint of this answer. So once you have all the pre-lab questions ready, the next thing is we move to do the online experiment using the fate simulation here. And as I mentioned, we're going to do this lab using the fate simulation. So let me open the fate simulation here. So here we have a simple pendulum. All right. So what are we going to do? We're going to set the length here. For my case, I'm using the length to be 0.70 meter. I'm going to make it 7.5. You can choose any length you would like to, but for my case, I have chosen 0.75 meter. Right? And then what you have to do, you simply move this one within 4 degrees. It has to be smaller than 4 degrees. That 4 degrees is good. And then let it oscillate. When it oscillates, you can go to the period timer and then click onto the period. So what it does, it calculates the time period. So what does the time period means? How long does it take to complete one complete oscillation is the time period. That means from this position coming back to this position, this is the amount of time it takes. Just to make one complete oscillation is the time period. In this case, it is 1.73 seconds. All right. So go back here. So you have to, so for your case, you have to choose the length to be 1 meter. I have chosen some arbitrary length, I think which was 0.7 meter. So write down your answer here and then use this equation. This is the relation, in fact, between the time period, length, and acceleration due to gravity. So using this equation, I can solve for the acceleration due to gravity. So if you solve for g value, which is acceleration due to the gravity, this will be 4 pi square L divided by t square. And in this equation, t is the time period, 2 pi is a constant, L is the length of the simple pendulum, and g is the acceleration due to the gravity. So now we know all the parameters here. We know 4 pi is a constant, L in my case, in this case, L is 0.75 meter. All right. And then a time, the time period in my case will be, this is the time period, 1.73. So once you plug in all the values, you'll get the you should be able to measure it. So probably you should be getting about 9.8, 9.78. That's the value you get. What is the average value? So you should write down, let's say you get 9.78. I'm simply making, do not forget to write down the units. What's the unit? The unit is meter per second square. All right. So what is the standard value? So in this case, the standard value is 9.81 meter per second square. Meter per second square. So now I have both measured value. This is my measured value and this is my standard value. And using these two measurements, I should be able to calculate the percentage error. So just simply plug into this percentage error equation and you should be able to calculate the percentage error. All right. So we completed this portion here. So now let's move on. So in the second half, what you have to do, you have to see the effect of pendulum length onto the time period. So how does the time period changes once we change the length of the pendulum? So in order to study this variation, what I have done is changing the length by 0.1 meter. So I will start with 0.1 meter, then go to 0.2 meter, and then keep measuring all this value. So you have to, what you have to do, so start with 0.1 and then go and hit this period, and then it measures the time period. All right, and again, so this is for the time period is for one complete oscillation. And now, once you have this value, go to the 0.2 meter. So you simply can go here and change it, 0.2 meter, and then come and hit this period button. It measures again, in this case 0.89, and you have to keep doing till you get to 1 meter. And already have done those things here. So let me open this one here. So once you have measured the time period, so here it is. Oops, it's just taking a little bit time. Okay, here we go. So we have the length, and then I measure the time period. Oops. And then you have to calculate the t squared. How do I calculate the t squared? All you have to do, I already have done it, but for your understanding, I'm going to do it one more time. So simply do, put the is equal to, select this one, and a square, and then hit enter sign. And then once you have, you simply go and click it here. That way, it gives you the t square. So the next part asks you, how do I plot a graph of length and the t square? So now what I have done, I have copied this one. So let me do one more time. So what you do, you length and t square here, just copy these two and paste anywhere you like to. And then make sure that you paste only the values here. Sometimes it also copies the equation, the formula. So make sure that you only copying the values and write down here t square. All right. We have to plot a graph. So select these two columns, go to insert, and go to the scatter diagram. And now this is my plot here. Okay. I'm going to delete this one, the first one. And now you have to put the axis titles here. So you can go to the plus sign, make axis titles. The axis title here is, in this case, this is the t square. All right, or time period square. And along this side, along x-axis, this is x-axis, that's the length. And you can put the L. And the axis title, it should be the length versus t square of a simple pendulum. All right. The next thing we're going to do is see how does this data point vary. Is there any fit of this data? So go here and click on the plus sign, or you can go to here too. So if you double click here, you see the add charted element. So go to this trend line here and then make a linear fit. You see the linear fit fits really well here. The next thing will be find out the equation for this one. So I can go to select this more options here now, more options on the trend line. I think it takes a little bit of time sometimes. Okay, let me cross this one and do one more time. More options. Now display equation. So that way I got the equation here, 4.03. So you have to make a note of this equation. Okay, so far we have plotted the length versus t squared and got the slope here. The slope here would be, so if you look at this equation, let me make a little better, bigger one. Okay, let me see if I can make it bigger. So 4.03, the slope, I'm simply writing down here, is 4.0316. That's the slope here. Because this equation is in the form of y equals to mx plus c. So the m is this one, which is the slope. All right? Okay, so let's go back to our lab. So you have completed this table. After completing this table, we have to move to the next question, which asks to plot a graph, which we already did. So now, once we have the slope, it says to find the slope. We already know the slope here, 4 pi squared. So what's the answer? In my case, my answer was 4 point something. You see, 4.03. Your answer would be different because of this data here. Okay. So make sure that you have your own answer. This is for my case. Your case could be a little different. You may get slightly different value. All right. So once you have a slope, you can find out the acceleration due to gravity. How? The acceleration due to gravity is, so you see, let me go a little back here. So we have the t squared versus this equation here. So where this equation is coming from? This equation is coming from here. This equation, that's the how does the length of a simple pendulum changes. So if you simply solve for the g, you'll get this equation, and if you solve for the t, you'll get this equation. If you solve for the t, you'll get this equation. Now if I look at the t squared versus L, then my slope would be 4 pi squared over z. So that is my slope here. So and now if I solve for the g, I get 4 pi squared over slope. So once I plug in 4 pi squared and my slope in this case is 4 point something, 4.03, I will get the acceleration due to gravity. And in my case, I got about 9.80 meter per second square. Okay, so that's the answer I got, which is very close because the standard value is 9.81 average. Okay, so let's move to the next question now. Find the value of g. We already got the answer. What's the direction of tangential velocity and net acceleration at the lowest point? So we have to go to the simulation one more time. So here, if I'm simply drawing this one here, making a larger swing. So you have to plot, take the picture of or a snapshot of the velocity and acceleration at the lowest point. So this is the lowest point here. So make it slow. Okay. So what do you see here? So at the lowest point, the acceleration is in the direction of the length here. You see, in the upward direction here, or you can call towards the center of oscillation. Okay, so the net this is the net acceleration. So at this point, the net acceleration is towards the center. Okay, and now the velocity could be along this way, horizontal direction, or it could be along this way, you see the velocity does changing. Let me make it normal. You see the velocity depends upon in which direction the pendulum swings. So the velocity direction is going this way or this way. All right, so you just try to take a snapshot of this one and then attach it, or you can draw by yourself and draw an arrow here. So for example, the velocity direction will be this way at this point, and the acceleration direction will be along the radial direction. So the velocity and acceleration are not necessarily in the same direction. Now take a look at the next question is the direction of the tangential velocity and net acceleration at the highest point. So highest point. So let me make a little bit larger string so that we can see a little better. So the highest, if I look at the highest string here at some point, let me make it slow. So you simply have to take a snapshot of this one. Okay, almost. So at this point, this is the direction of the acceleration, and the green one is the velocity direction, which is almost zero. In fact, at the highest point, the velocity would be zero, and there would be the maximum acceleration. So acceleration, even in this case, is not a constant quantity. It is changing. The net acceleration is changing. The net acceleration here is the result of radial acceleration and the tangential acceleration. So in short words, at the highest point, the velocity is zero. And when the velocity is zero, you have the maximum acceleration. At the lowest point, when the velocity is maximum, you have the minimum acceleration. All right. So that way you should be able to answer all this question. Take a picture or take a snapshot and attach it here. So now let me explain a little bit here. So why you have two acceleration, or why does the acceleration changes? So I'm going to explain this one just for your understanding. So here, this is a simple pendulum oscillation. So this is the object, and if you look at this object here, and this is a string, the weight or the acceleration due to gravity is always in the downward direction. And let's call at this point the angle is phi. So I can resolve this acceleration due to gravity into two components, one along the radial direction and one along the tangential direction. And if you resolve the two components, this component will be g cosine phi and this component will be g sine phi. So we have two components, and because as the pendulum swings, the angle phi does changes. At this point, at the lowest point, my tangential, my phi will be zero. So my tangential acceleration would be zero, and you will have maximum radial acceleration, g cosine phi, which is acceleration due to the gravity. All right. So the tangential acceleration is changing from position to position. Okay. So now when this pendulum is at the maximum highest point, the phi is maximum. When the phi is maximum, you will have the maximum tangential acceleration. So the tangential acceleration and in fact the radial acceleration both change it. But one thing always remember, it doesn't matter what location it is. If you calculate the total acceleration, the total net acceleration, it will be always exactly 9.81 meters per second square. It is simply the two components, the tangential acceleration and the radial acceleration oscillates, and for this reason we also call this is a simple harmonic motion, okay, or periodic motion. So this is it for this video. If you have any questions, any comments, write down in the comment section below. Have a wonderful time ahead. Thank you very much.